हेलो। अब मैं लाइव आ गया हूँ। कितने लोग हैं अभी? जो कॉन्करेंट व्यूअर मतलब आठ आठ में दिखा रहा है। हाँ हाँ। मेरे बैकग्राउंड में आज थोड़े वॉइस है। मेरे बैकग्राउंड में थोड़ा वॉइस है आज, वो कुछ ड्रिल चल रहा है बैकग्राउंड में। चलो फिर मैं। हाँ, थोड़ी थोड़ी देर बाद स्टार्ट करूँ क्या, या क्या करूँ? टाइम तो हो गया है। ठीक है। हाँ हाँ। ओके। थैंक यू, बाय। हेलो गाइस, गुड इवनिंग। So I am Shivashis and we'll start our today's session maybe in next 2 minutes. We'll just wait for a few more viewers and we'll start our today's class. हेलो। हाँ विनायक। हाँ हाँ, बोलो बोलो। नहीं नहीं, चालू नहीं किया। अच्छा, करूँ चालू? ओके। ओके। हाँ। ओके। ओके ओके। हाँ। Hello guys, good evening. So I think we'll not we have already waited like almost 5 minutes and we'll quickly start our today's session. So I think all of you are a bit excited for today. Yes, today we are going to learn logistic regression. As as we have already in machine learning, we already had two classes before. One is introduction of machine learning, and the second one is linear regression. So I think you must have a little bit hang of this concept, like how the machine learning works. So now moving forward, we are going to learn uh, linear regression then logistic regression, then after that the KNN clustering and classification problem. All right, so we'll take around like 7 to 8 session, and we'll discuss each and everything with the concept and with each machine learning concept, or like the case studies as well. All right, yep. So today we are going to learn logistic regression. So like as I told you, we use linear regression for like continuous variable output, like when we have to predict like maybe the weather forecasting, maybe the sales prediction, or like such kind of thing. So we specifically use linear regression because it like learns from historical data and predict the future. So that is why we called as a the predictive modeling as well. And since like today we are going to learn a linear regression, so it is more or less like same. So what we are trying to achieve here, so linear regression is basically we used to predict the result for categorical variables. Like maybe in linear regression we specifically use for the continuous variable output, but here the important thing is we used one or more continuous or categorical independent variable. So when we talk about the independent variable, that means whatever we plot in y-axis. So and we have the dependent variable that is a x-axis, and we have the independent variable that is a y-axis. So every change happened in x will reflect in y. So in categorical, like as I told you last time, the categorical variables means like everything which is in binary form, maybe a yes or no, or maybe a true false, like such thing. So we'll learn more about this. So in other words, we can also say it's a multiple regression analysis, but with a dependent variable is categorical. So when we talk about the dependent variable, that means in our x-axis we have we should have the categorical variables, right? So when we talk about this class, and this is also called as the classification algorithm because it is used to predict a binary outcome, like as I told you, 1 or 0. Hello. Yeah, very good evening, guys. I think you must have excited and ready to start our today's class. So in my first class, I have already discussed what is the machine learning, the introduction of machine learning, and the second class we have learned about the linear regression. So like going forward, we will learn more about the algorithms like linear regression, logistic regression, then clustering and k nearest neighbor. So we'll cover each and every algorithm in detail. So it will take around 6 to 7 classes, and the more importantly, uh, like we will discuss with the theoretical part as well as we will discuss the case studies as well. All right, yeah. So in the today's class we are going to learn about the linear regression. So it is more same like a linear regression. In linear regression, what exactly we are trying to achieve? So we have the continuous variable output, like we're trying to achieve the continuous variable independent variable output, wherein the use cases like weather forecasting and sales prediction, when we have the historical data and we have to predict the future, like the future behavior. So you can say that is why we specifically called as a predictive modeling. So unlike logistic regression, it is more or less same. Again, we have to predict our result, but the most important thing, categorical dependent variable. So when we talk about the dependent variable, that we plot in x-axis, and our y-axis is basically an independent variable. So every change happen in x will reflect like in y-axis, correct? So like in other words, you can also say this is like a multiple regression analysis, but with the dependent variable is categorical. So when we talk about the categorical, so that means it may be in the form of like yes or no, true or false, maybe like two categorical value, maybe a three categorical value, something like that. So in my dependent variable, that is a x-axis, we specifically have the dependent variables, which is categorical. All right. And logistic regression is also called as the classification algorithm because it classifies from one variable to another. And as I told you, we can predict our binary outcome here, like 1 0, yes no, true false, like something like that. And but the question is why it is needed, like when we can predict, in the numerical form, because the machine learns either the form of 0 or 1 in logistic regression, right? And we might have a lot of categorical values. We have to convert it into a 0 and 1, and then we can do our modeling and our analysis. I will explain each and everything in detail. So, to represent binary and categorical outcome, we use dummy variables. So as I told you, so dummification is the method, like dummification, label encoder. These all are the techniques where we can change our categorical value to numerical values. And so you can also think in such a way, like a logistic regression as a special case of linear regression when the outcome variable is categorical. All right. Like in simple words, you can say predict we are predicting the probability of occurrence of an event by fitting data into a logit function. We also call it as a logit function. So what is logit function? Because it's a the linear regression means, sorry, the logistic regression itself means as we take a logarithm. We take how, because in last session we have seen y equal to a plus bx, right? And here we can take the logarithm in both the side and we can see the output, like how it works. So for example, let's say an employee may get promoted on the basis of age, years, and maybe his last performance rating, right? So what we are trying to calculate here, whether he will get promoted or not. So we have the two values, right? We have the two categorical values. One is promoted, one is non-promoted. And yeah, and here the algorithm we are using, that is, you can say what, the logistic regression is based on the maximum likelihood estimation. If you remember, in the linear regression we also talk about the algorithm that is a least square estimation. It is as similar like the maximum likelihood estimation. So that means it maximizes the probability of y given x. Again, when x is the likelihood every change, which is a dependent variable, whatever happen in x, it will automatically change in y, right? Yeah. So you can see here, this is the typical equation, logit p. And when we talk about the logistic, we deals with the multiple multiple regression variable. It is not as like a single variable where you can find y equal to ax, but we are talking about the multiple regression. That is why b0 plus b1 x1 plus b2 x2 and so on. So, and we can take the logarithm on both the side, and so this is our simplification, this is our maths behind it. So we can achieve something like this, which is equal to p equal to 1 by 1 plus e minus, because it's a reciprocate, right? So we just reciprocated, so that is why this is the formula. So the probability of dependent variable equaling a success or event. So this is something math, so it is good to have this knowledge. But yeah, we can also see how logistic regression work in Jupyter Notebook when we build the model. And if this is in the form of S, you can select something like this. So this is a typical graph of logistic regression curve, which is also called as sigmoid function. All right. Yeah. So now we talk about the distribution. What is distribution? Yeah. So distribution, it's here a binary logistic, how it works exactly. Binary logistic regression model assumes binomial distribution of the response with n number of trial and probability of success. So if you remember, we discuss the normal distribution in linear regression, which is the bell-shaped curve, which is also called as QQ plot. But here we are we doesn't need the normal distribution. We have the S-shaped curve, which is also called as sigmoid, and n number of trials and probability of success. So logistic regression is in binomial family of GLM. So GLM is something like which we'll learn, like it's a more advanced logistic regression form, you can say. So if you can take an example, like suppose if you flip a coin, so what is the probability of getting one or more heads? So the distribution, what is the distribution out of it? So here, it will like give you the more sense. Then you can maybe understand what is binomial distribution and what I'm talking about. So n equal to 2 because it can come as like a head or tail, or maybe like a two head or maybe a two tail. And what is the probability? So like 1 by 2, that is 0.5, right? Like the binomial distribution consists of probability of each of the possible number of success on n trial for independent event that each have a probability of p. So this is general intuition behind like how this binomial distribution work. And what is the interpretation here? Like interpretation of logistic regression estimates of if x increases by 1 unit, like that is your dependent variable. The log odds, like here we are talking about the log odds because we are taking the logarithm in independent variable which is on y-axis. Log odds of y in increases by k unit given the other variable in the model are held constant. Like if you can see this equation once again, so like every change happen in x, it will reflect in the form of p inversely, right? Because and you can see these all are the constant like beta naught, these all are the constant, so constant will just keep remain same. So we can say in logistic regression the odds ratio is easier to interpret, and this is also called as point estimate. So this is just for the additional knowledge, that's it. But yeah, and here also the most important thing we should talk about, that is the assumption. Like in linear regression we have learned about the assumption called residual assumption. You must have remember how we check the the normal distribution thing, and if the line fits, right? And like maybe you can see velocity, these all are those are all are the assumption. So similarly in logistic regression also we have the few assumption we should always keep in mind. We always take the logarithm form. The logic transformation of the outcome variable has a linear relationship with the predictor variable. When we talk about the predictor variable, that is exactly means like the x-axis, x variable. So what we do, like we transform the numerical variable to 10 to 20 groups and then check whether they have a linear or monotonic relationship. So like this way. And the most important thing, like it doesn't have any multi-collinearity problem. Like in linear regression we have the multi-collinearity, that is why we deal with the r square, adjusted r square and all such thing. And here like what happened, and there is a no such influential observation. I was talking about the outlier. So outlier is basically when you draw a a box plot, we can find the outliers. But here we do not bother about the outliers because it doesn't has the multiple variables, it just has the two variables 0 and 1 like at the end. So everything boils down to 0 and 1, the categorical variable, when we are dealing with the logistic regression, right? Yeah. So now the thing is like how we approach when we build a model, when we build a logistic model. So like as you know, generally we read our data set, then we do the lot of data manipulation and the data pre-processing, and we do a few data visualization. Then after that we build our model. Before building our model, what exactly we do? We randomly split. And here you should keep in mind like it will randomly split data into training and test, like let's say 70 and 30 in this form of ratio, and measure prediction accuracy on training and test data. So here the error, the proportion should be roughly like divided into the same like training and test, right? And here when we talk about values, this is most important guys, like you should focus on this particular thing. So there are several ways of dealing with missing values, like huge, if your data is a very large, so there might be chances like you have the lot of missing values. So then we do not use the variable for building the model. So that what exactly that means, like if any column, if I have a Excel sheet, like I will show you also, like today I'll show you the Excel sheet with the case studies, each and everything, like what kind of data we get and what should be my approach. So when suppose if you have any column, let's say one is a age person and his salary and maybe his location. Like there are a lot of employees, there are a lot of employees, and with the multiple employees, they have their salary, they have their age, and they have their location, like where they come from. So if we have the lot of missing values, like let's say in a location section, like in the location column, so specifically we just drop that column. We do not consider that particular column. Why we don't consider? Because at the end, the less number of variables we have, the less number of columns, less number of features we have, my model will give me the better performance. Because the more messy I have the data, there's a high chances like my accuracy will just goes down, right? So if the percentage of missing value is small, 5 or 10%, then we can still consider. But if I have the missing values maybe a 20%, 30%, and maybe a 60%, something like that, so we do not consider that particular column. Yeah. So what we do, like suppose if I have the 5 to 10% missing value, what exactly we do? We replace them, because you always have something, you always have a data to do some analysis and build some model. If you don't have any data, if you have a null value, if you don't have anything, then we should do something about it. So what exactly we have to do? We replace with them with the missing value, either mean, median, or mode. So specifically in logistic regression, because we deal with the category value, so either we deal with we impute, basically impute the median or maybe mode sometime. Mean, like it depends. Yeah. So now what are the performance metrics here? So these are the, like we have the 2 or 3 performance metrics we should always keep in mind. The first one is AIC, which is Akai Information Criteria. So what is that? Like AIC provides a means for model selection. Like it is as similar like the R square and the adjusted R square. Like because R square means it will select you the criteria wherein you can build your model. Like the model selection, like how your model is good. Your model is good or bad. If your R square is like suppose 0.80 percentage, that means your model is good. If your R square is maybe a 0.40 percentage, then means your model is not fit perfectly. Then again you have to go back to the basis, and you have to do some pre-processing and come up with a more accurate and a more precise R square, right? And now I think you must have remembered, like I have already discussed in my first class and the basics of machine learning, which is about confusion metrics. So guys, this is the most important thing you will like always learn when you're dealing with the categorical value. So it is nothing but a tabular representation of actual versus predicted values. So this help us to find the accuracy of the model and avoid overfitting. So I was talking about the accuracy, right? Like how you identify like your model is accurate, whatever the model you have built, whether it is correct or not. So it should have the evaluation metrics, right? So that is when the accuracy come into the picture. And with the help of this confusion matrix, we'll discuss. All right. Yeah. So yeah. So we can calculate the accuracy of your model with this tabular form. Like you can see, there is a like I have already shown you this a graph before. So you can see the actual and predicted. Like you can like say in a very layman term, like a good and bad, or maybe a good or bad, right? So like a true positive, false negative, false positive, and true negative. Like I have already explained you, so you can go back to my first class and you can just have a look like what I have explained you like about the confusion matrix. But here we are talking about like how we can identify the other inference. So when we talk about the accuracy, so this is the formula of accuracy specifically. Like when we talk about the accuracy, that means like the true positive plus the true negative divided by the whole, like the true positive, false positive, false positive, and true negative. All right. from confusion matrix, so what we exactly get, like specificity and sensitivity can be derived as illustrated below. So you can see, like, for the true negative rate, this is the formula. Like we also call, so we have to, like, keep in mind of this term, specificity and sensitivity. Just forget about this true, like the true negativity and whatever it is. So when we talk about the specificity, so that means your A, that is a true negative, divided by true negative plus false positive. Understood? Similarly, like 1 minus specificity, it is just like, just you can just flip it. Like this is also called as like a Bayesian theorem as well. So you can say like specificity in terms of false positive rate, which is like just opposite, like B, which is a false positive divided by true negative plus false positive. So this is all about the formula of specificity. And when we talk about the sensitivity, it is like, again, it is just when we talk about like the true positive divided by false negative and true positive. And similarly, for false negative, it is false negative divided by true positive and false negative. So why we are doing this? What exactly we're trying to achieve here? So we should always keep in mind these two terms. One is the accuracy. This is the formula of accuracy, and the second one is specificity and sensitivity. So that specifically plays a very crucial role to driving our ROC curve. Now, what is ROC curve? So this is our, again, third evaluation matrix. So ROC curve means, wait a second. Yep. Yeah, a receiver operating characteristics. So which summarize the model performance by evaluating the trade-off between true positive and false positive rate. That means trade-off means it's a threshold. It will decide the threshold between your sensitivity and your specificity, which we have just learned now. So for plotting ROC, it is advisable to assume p greater than 0.5. So this is a standard, and you can consider as p 0.44 also, 0.3 also. But p 0.5, like, which is the p value, which all that means like it's the predictive power of all the possible variables, like all the values. So that means like p 0.5, which is means the where our model perfectly fit, right? So for the time being, you should just keep in mind with the p and such thing. So because here we are more focus on what is ROC, what is AUC and such thing. Yeah. So ROC summarize the predictive power for all possible values when p greater than 0.5. So I will explain you in the graph like what do you mean by p greater than. The area under curve, which is AUC, referred to as index of accuracy. So what does this mean? Like I will show you the picture, then maybe you will have more sense. So this is this thing that you should keep in mind. Like higher the area under curve, better the prediction power of model, right? And below is a example. Yeah, so we'll just go to the next slide and we'll see. All right, guys. So yeah, this is the ROC curve. So this is a typical ROC curve. If you can see, yeah. So like I have plotted my x-axis like from 0.0 to 1, which is always same, and here like again like 0.0 to 1 in my y-axis. If you can see here, the important thing I have told you, we plot ROC curve like in between false positive rate and true positive rate, which is nothing but specificity and sensitivity, right? Because here we just have learned, right, what is your false negative rate, sorry, the false positive rate, which is specificity, and true positive rate, which is sensitivity. If you can see here in this graph also, so you can just make a sense out of it. Yeah, so this is a false positive means like sensitivity and the specificity. We plot this graph in between these three, in between these two. So this is the typical ROC curve, and the area under curve, like this region, which is called as AUC, area under curve. And this curve if you can see, like there's one line, like the ROC of a perfect predictive model has TP equal to 1 and FP equals 0. That means, like, let's if I would say the customer has a diabetes, right? And we predicted as like he doesn't has the diabetes. So it might gone for the toss, right? Like it can risk his life. So if we predict as the customer has diabetes, which is equal TP, which is true positive equals 1, that means we can do something about it. We can get him admitted and we can, like, uh, do a treatment or maybe medication, like such thing. But if we predict falsely, then definitely it will cost his life. So that exactly means this curve will touch the top left corner of the graph. So what do you mean by that? If your graph is something like this, if it, like, cover the more here, it will, the more it will cover from this left hand corner, like the more C curve. So which in this curve we also called as elbow curve. The more elbow, the more inclined elbow it has, and the more AOC, that is the area under curve, which we get, that means our model is good. All right, that means our model performance is really good. So which is also mentioned here, like the model performance you can also consider likelihood function. It is called so because it selects the coefficient value which maximize the likelihood of explaining the observed data, right? It also indicates the goodness of fit as its value approaches 1. If the value close to the 1, the model, like, performing really good, and if the like value more close to 0, that means it's a poor model. Yeah. So it plots true positive rate and false positive rate, which is again nothing but specificity and sensitivity. We can take an example as well if you want. It ranges from zero point 0.5 to 1. It can be from zero point 0.4 to 1 as well, where zero point 0.5 correspond to the model randomly predicted, which is R nothing but RP, the response, and 1 correspond to the model perfectly discriminating the response. So this is the typical formula. Like if you can, like, suppose this is the graph, something like this, which is not perfect elbow curve. But if you can see, like my A, which is 0.90 minus 1, which is excellent, like which is somewhere close to here, which is 1, and 0.80 minus 0.90, which is good, which is something like this here, which is not 1, but yeah, more or less close to 1. And then this thing, then this, then this, and this is my poor. Like if I have a data point here, then 0.1, which is like, if you can minus 0.50 to minus 0.60. So my model is like, we have predicted a very wrong assumption. So we need to consider again, as I told you, AUC, like this thing, the area under curve, which is called AUC. Yep. Now we'll just little bit talk about the application and we'll just move forward our code. So application like here, which is a predicting, like there are a lot of application in a real life cases, but yeah, like maybe you can predict the stock price movement, which is up and down, predict whether a patient has diabetic or not, predict whether a customer will buy or not, predict the likelihood of loan default. So if you can see in each and everything, we have the two bias. One is yes or no, up or down, diabetes or non-diabetes, will buy or not. So always, like, the two categorical values 0 or 1, 0 or 1. It's a binary classification problem. So whenever you see any binary classification problem, so you should specifically approach this logistic regression, like rather than a linear regression. There are other models you can also build, but yeah, this should be your first choice. So guys, I think we have just done with the theory part, and now we'll just quickly have a look on our data sheet and we'll move forward to our code. Just hold for a moment. Yeah, so guys, before, like, okay, just a second. Yeah, so I just want you to know, guys, that you are able to see my Jupyter notebook. Can you just please, gives me a, can you just send me a, comment if you are able to see my Jupyter notebook? Are you guys able to see my notebook? Okay, so like here, this is the problem statement which is predicting this data set which I specifically got from a Kaggle. So in Kaggle there are a lot of data sets. Like somebody has asked me whether it is a healthcare data set. Yeah, it is a healthcare data set. So so you can get a lot of different data set if you want to build a categorical, sorry, a logistic regression, or maybe any other regression techniques. So what we are trying to predict here, like predicting diabetes. So I'll just quickly take you through the what is the problem statement, what is the question, then I'll show you the data set. After that, I will go through the code. All right. Yeah. So predicting diabetes patient readmission. So what exactly we are trying to achieve here? So it is as important to will if the patient will be readmitted in some hospital. The reason is that you can change the treatment in order to avoid a readmission. Suppose if we wrongly admitted a person which is not sick and which doesn't has a diabetes, so unnecessarily we can consume the more bed. So you whenever you approach any problem, so you always think of the business side out of it, like why exactly we are doing it. So as a data scientist, you should always think just not to build the models and just get the accuracy. Like you should always go deep and dive into what is the problem statement, and you should always collect the data. You should always ask the more information to your clients, or from wherever you get the data, and you should always focus on your domain knowledge first, then you can approach your problem. Yep. So the reason is that you can change the treatment in order to avoid the readmission, right? So in my database, we have around three different outputs, the three different types you can say. One is no readmission, one is readmission is less than 30 days, and one is a readmission in more than 30 days. Right. So the problem is to figure out here, like where the patient will not be readmitted, or if they are going to be readmitted in less than 30 days. Because if the patient is really sick, so we have to treat him as early as possible. Right. So this typical data set, which is represent the 10 years of data of a clinical care of 130 US hospital, like something. So these all are our following criteria we should always keep in mind. One is it is an inpatient encounter, a hospital admission. It is a diabetic encounter, that is one during which any kind of diabetic was entered to system as a diagnosis. A length of stay was at least 1 day and at most 14 days, which is less than 30 days. And laboratory tests were performed during the encounter if a diagnosis as a diabetes, and what kind of medication he's taking and during his encounter. And these all are 50 different attributes, which is nothing but our features or also you can say as our column. We deal with the row and column, so this is my column. So now I will show you the data set. A quick look. Just give me a moment. So guys, if you have any questions, so you can just keep like posted on a comment box, and later like maybe a 10-15 minute we can discuss all of them. Yeah. Okay, I think you must have able to see my Excel. So yeah, so this is my diabetic data, which has around 50 columns. If you can see, these all are my columns, but if you can see, the most important thing here you should keep in mind that there are a lot of the numerical values. If you can see the admission, maybe discharge, and you can also see, like suppose let's say weight, it has a question mark. It is nothing but it has a null value, like it doesn't make anything, so in that case we don't need this. Like if you can see, like it has around how many rows. Okay, let me check. It has around, let's say, these many rows, like 5088350. And if I have these many like missing values or these many junk values, it doesn't make any sense to my model. So rather I would just drop this column. But similarly, not only this, if you can see in this here, like a medical, and what is the name called, let's say medical specialty or something. Yeah, medical specialty. It has also a lot of null values, but it also has the few uh, like a cardiology, surgery, family, and lot of other categorical values. So we'll see like how we approach this. All right. And also, if you can see here, yeah, so a lot of has the like these all are like categorical value, like no, steady, no, down. So we'll see like how we what we can do with this all this data. So also in the, so this is my target column. Like last time I was told you, right? So we are dealing with the supervised learning. So when we are dealing with the supervised learning, so we should have always the like the target variable. So in your question, like you should always ask your client, like what exactly are trying to do, because if you don't have any intuition what exactly you are trying to achieve, so you cannot identify, like here my target variable is readmitted, so I want to address whether the readmission should happen or not, or if happen then in what condition. So you can see there are a lot of conditions, like greater than 30 we just have seen in our problem statement, greater than 30, less than 30, right? Yeah, so this is my target. So this is only a training data, and last time whatever we have discussed we deal with the training and test data, but here we have just the train data. Okay, and we have a lot of other malicious and junk values. We'll see what we can do. And here, like, because I will not again come back to this Excel sheet, so that is why I'm just showing you. If you can see here, there are the first two columns, encounter and patient. What is that? Patient NBR. It has, it is something like that, the ID. Like, the encounter must be encounter ID maybe. Yeah, encounter ID. So it, like every person has their unique ID. Like even person name or ID, it doesn't make any sense when I'm building my model. And patient NBR is also like something like that, similar like that ID. So we don't need both this thing. So we'll see what we can do. All right. So now I'm going back to my Jupyter notebook. Guys, just wait a second. I'm just checking whether you can see my Jupyter notebook or not. Okay, so guys, like I think a lot of uh, guys like they keep telling they are not able to see my screen. Please share again. Okay, I just wanted to know, can you see my like screen? This like it has written diabetic patient vision NLP D3. Are you able to see? Can you just please notify? All right, guys. Okay, so we'll not waste time. We'll just start. Okay, so yeah. So like here, this is our generic approach as usual. So we just import the file like numpy, which we specifically do for our numerical data pre-processing, and pandas again, like we are dealing with the pandas and numpy. So pandas is for label data pre-processing, and matplotlib is for visualization, where we can plot our nice graphs, visualized graphs, statistical graphs, you can say, right? And okay, yeah. So here we are reading our file, read the file and create pandas data frame. So like pd.read underscore csv, and this is my location. So I think guys, you must know like how to read the file, right? Just a second. Hello. हेलो
पहले माइक को जो पिछले वाला वीडियो में गया था
समझ नहीं आ रहा। हाँ, मेरा मेरा स्क्रीन शो हो रहा है ना?
हेलो
स्क्रीन शो हो रहा है कि नहीं? जल्दी बोलो।
इसका इस हो रहा है क्या? वो जुपिटर नोड ओपन नहीं किया आपने?
हाँ, जुपिटर नोड ओपन किया है ना।
हेलो हेलो
हाँ, जल्दी बोलो। ओपन ओपन किया है ना मैंने जुपिटर नोटबुक।
मुझे बताओ ओबीएस में जाओ।
नहीं नहीं, सब कुछ ठीक है, सब लोग बोल रहे हैं कि उनको दिख रहा है।
दिख रहा है ना? ओके ओके।
हाँ, मैं कंटिन्यू करता हूँ अभी। Okay guys, there was a problem like I was trying to fix it. Yeah, I think so we can resume now. Only able to see the home screen of Jupyter notebook. What do you mean by that? Not the notebook. So you mean you can't able to see my screen? Can you able to see something like this? Guys, just please quick, just let me know like are you able to see my screen or not? when you launch the notebook where you select the notebook saved that screen. No, okay. Okay, all right. Okay, just guys, give me 2 minutes. Just please hang up. I'm just trying to fix. हाँ, स्क्रीन दिख नहीं रहा है, क्या हो गया? हाँ, ओबीएस में गया। ओबीएस में कुछ नहीं देखो, ओबीएस में वही वाला स्क्रीन दिख रहा है कि जब मैंने लॉन्च किया लोकल होस्ट, बट मेरा वो जुपिटर नोटबुक नहीं दिख रहा है, क्या करूँ? दो क्रोम खुला है। तीन, हाँ, दो खुला है। एक क्रोम को कैंसिल कर दूं? दो ही है, एक को कैंसिल कर दे रहा हूँ, दूसरा वाला ऑटोमेटिकली शो हो जाएगा। हाँ, वो वही वही वाला खुला है, कुछ फालतू सा। हाँ, हो गया अभी अभी आई थिंक शो होना चाहिए, देखो। अभी भी शो नहीं हो रहा है क्या? एक बार देखो तो। अच्छा, मैं क्या करूँ, कुछ समझ नहीं आ रहा, बताओ जल्दी। मेरे को अपना ओबीएस ही नहीं दिख रहा है। ओबीएस पे मैं गया तो ओबीएस में अभी मुझे वो। हाँ। हेलो। ओबीएस में ये दिख रहा है। ओबीएस में भी कुछ दूसरा स्क्रीन दिख रहा है। मेरे गूगल। हाँ, वही दिख रहा है। हाँ, वही दिख रहा है, वही दिख रहा है। पहले अभी दो ही ओपन है, पहले तीन ओपन थे, अभी अभी दो ही ओपन है, एक लाइव स्ट्रीमिंग यूट्यूब स्टूडियो और एक डायबिटीज पेशेंट। हाँ, उस पर गया। जुपिटर होम का है। हाँ, उस पर क्लिक किया, बट उस पर भी वही दिख रहा है, पुराना दिख रहा है। आप एक काम करो, आप एक बार दोबारा जाओ और जरा मेरे को देख के बताओ। ठीक है, दोबारा मेरे को अब जरा फोन रखो और मेरे को बताओ, मैं जरा फिक्स करता हूँ इसको। जुपिटर नोटबुक दिख रहा है, उसका होम नहीं, वो होम दिख रहा है, मतलब मेरा कोड नहीं दिख रहा है, कुछ और दिख रहा है। हाँ, हाँ। अभी दो विंडो है, एक विंडो में जुपिटर नोटबुक है, और दूसरे विंडो में मेरा वो खुला हुआ है यूट्यूब। तो अभी मुझे अभी अभी मेरे को यूट्यूब वाला स्क्रीन दिख रहा है अपने ओबीएस में। हाँ। अच्छा, तो मैं इसका यहाँ से लिंक कॉपी करके ले आऊँ? कर दिया। हाँ, अभी आ गया, ठीक है, ठीक है, हाँ, रखो रखो, अभी आ गया। ओके, ओके। Hello. Yeah. Yeah, guys. So I think like it was little problem with the setting. So I think you must have able to see my screen now. Okay, guys, so we can start now. Okay, so I'll just quickly brief you again, like the problem statement we are what we are trying to do and what we are trying to achieve. So we are trying to achieve the readmission, the predicting diabetes patient readmission. So it is important to know if the patient will be readmitted in some hospital, right? So this is my target, like readmission is my target variable, and we can see like what we can do. So this data has been taken, this data like of around 10 years of data we have taken from some clinical care. So I took this data from Kaggle. Okay, so we'll just see our first chunk of code. You can import numpy as np, like we use np for our numpy, we use for our numerical data pre-processing, and we use pandas for our labeled data for pre-processing. Yeah, and matplotlib is for visualization. So as you know, like how we can read the file, like data equal to pd dot read. So this is my local where I have this particular. So this is this is my local file. So I just extracted, I just import a file from there, and if I read the data dot head, so I got like 5 rows, because typically when you mention, like suppose if you need around 9, so you can get from 0 to 8, because like 0 is the first indexed, then second, third, fourth, and so on. So you will got around 9 rows and 50 columns. So I have, my row is like more than 58,000, or maybe a 5 lakh something, I just forgot. Yeah, so if you can again see, because you can also have a look your data here. If you can see the data, like let's say this weight has a lot of null values, this admission type id, it has categorical value. And if you can also see, so this is my typical data, readmitted, this is my target variable. Okay, so now you can check your shape, check the dimension. So like these many rows and these many columns you have. You can also take the information, and we can also check you can also check your description, like you can see like how many data you have, mean, median, mode, everything you can check here. You can see, you can also check here your count, mean, median, mode, standard deviation, first quartile, second quartile, third quartile, and maximum, everything you can check. And this is the first 5 row of data, like as I told you, like if you can mention like this is typically give you the first 5, or if you want to see, you can see your first 10 or whatever. Yeah, so now the response variable readmitted in the original dataset contained 3 categories. As I told you, like so my data has segregated into 3 categories. One is the patient who will admit within 30 days, which is around 11%. The second one is like the patient who can readmitted after 30 days, which is around 35%, and who will never admitted, they're around 54 percentage. Correct? Yep. So now yeah, so हेलो हेलो। हाँ, अभी क्या प्रॉब्लम हो गया? हाँ, नहीं बट अभी तो ओबीएस में दिख रहा है ना। अभी देखो, अभी देखो, अभी देखो, अभी अभी देखो जल्दी से। बहुत मुश्किल है यार सही में ये तो। अभी जरा देखो। अभी नहीं, अभी 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 जरा चेक करो ना। अभी अभी चेक करो ना प्लीज। नहीं, मैंने म्यूट किया है। हाँ हाँ। ओके। हेलो हेलो। नहीं मेरा कौन कौन सा एक्सेस देना है? मैं समझ नहीं पा रहा हूँ। कौन सा एक्सेस चाहिए बोलो जल्दी। अच्छा, दे रहा हूँ। क्या क्लासरूम में इतना डिस्टर्ब हो चुका हूँ मैं। टी- नहीं टीम का मेरा पासवर्ड डालो ना, एक्सेस तुम्हारे पास है ऑलरेडी। पासवर्ड सेम है। नहीं नहीं, पासवर्ड तुम्हारे पास ऑलरेडी है। कनेक्ट कनेक्ट करो ना। तुम खुद करो कनेक्ट। हेलो। मुझे कुछ आवाज नहीं आ रहा है विनायक, मुझे कुछ भी नहीं सुनाई दे रहा है। तुम हम्म, हाँ बोलो बोलो, अभी सब लोग चले भी गए होंगे, अभी क्लास क्या फायदा है लेके। नथिंग, कोई बोल रहा है यस विजिबल, कोई बोल रहा है नो विजिबल। पता नहीं चल रहा है कुछ क्या बोल रहे हैं। जल्दी करो जो भी करना है।
चल, हाँ, हाँ, अभी ऑफिस में है। हेलो।
हाँ बोलो बोलो।
शिवाशिष,
हाँ हाँ बोलो बोलो।
ऑफिस ऑफिस
ये है।
ऑफिस
ओबीएस में गया।
हाँ, उसमें दिख रहा है अभी।
नहीं दिख रहा है, इस पे ये दिख रहा है।
हेलो।
हाँ बोलो, ओबीएस में ये दिख रहा है देखो।
हाँ हाँ, नहीं हाँ, हाँ वो दिख हाँ, अभी क्या यूट्यूब पे जाओ, यूट्यूब पे है ना, उस पे जाओ, क्रोम पे जाओ। दूसरा वो ये वाला नहीं, दूसरा कॉम है जहाँ पे यूट्यूब लाइव है, उस पे जाओ।
हाँ। अभी क्या करूँ?
जो दूसरा टैब ओपन हुआ है, इस दूसरा टैब है ना, क्या
हाँ
नहीं है?
हाँ, इसको क्लोज करूँ?
क्लोज मत करो, दूसरा टैब ओपन करो इसमें।
ओपन कर लिया।
हाँ ये चालू करो।
अच्छा
हाँ
ठीक
ओके,
है।
हो गया। इसके काम चालू करो, अभी ऑफिस में जाओ। ये स्क्रीन रहा है ना?
हाँ ये दिख रहा है.
हाँ ओके चालू करो अभी.
Okay. Hello, yeah guys, I'm really sorry for the inconvenience. So yeah, we have checked all this thing. I think like I was telling about, I think you must have able to see my screen now. Okay, so if you can, like, we can check here. We have already seen our head. Now we can check the shape and we can check the information. And if you want, we can also check just wait for a moment, it is reloading. I can also check my data discovery. Like you can also check like the first, let's say the first 10 rows of data, or maybe like how many data you want to see. Yeah, so here like I was telling about the response variable readmitted in the original dataset contained three categories. One is 11% of patient, they were readmitted within 30 days, and the second one is like they readmitted after 30 days. The 54% of patient were never readmitted, right? So data dot group wise. So when we do group wise, so we are combine all this data together. So group by readmitted dot size plot kind equal to bar. So like plot like, so what we are trying to do here, so we will draw a plot where we can able to see like the 11% of data is distributed within this 95% in this category and 51% in this category, right? We can just plot a graph. So yeah, so this is the some kind of visualization you can see, like the 30%, less than 30% people, and the readmitted people, and then no. So this is the distribution of among these three categories, correct? Yeah. So now what we can do, since we have the three different columns, like we have three different categories, so we can boil down into a binary classification task. So recode this response variable so that it becomes a binary classification task. So that means 0 means no readmission and 1 means readmission, no matter how many days after being discharged, like after 30 days or less than 30 days. Because what we are trying to achieve, so we are just trying to achieve there is a no readmission and the admission, that's it. Yeah, so we just labeled our data like data readmitted pd.series 0 if value equal to no, or else 1 if value in data. If value in readmission, then it will assign as 1, or else it will assign as 0. And we assign all this thing into data origin, like this is the original data now equal to data. So we are passing in this argument data dot origin data frame, correct? So now what we can do, plot readmitted again to see the changes. So initially we have the three different categories. Now we have only two categories. One is readmitted and one is like no. So we'll see like how this plot will be. Again, the data dot group by. Group by means when you combine together. When you combine like the data into, and you jotted down the data into a one meaningful like the values, correct? Like data.grover readmitted dot size plot kind equal to bar, because we are trying to build here like a bar plot, the bar chart. So now you can see like the readmitted, these many peoples are readmitted and these many peoples are like they readmitted. So I was telling about all this thing, right? Like the encounter data, the patient NBR, pair code. So if you can see my data head, I have encounter data and patient data, which doesn't make any sense in my like data set to build a model. So specifically what we can do, we just eliminate or we just remove these two columns. So that is why I'm dropping here. Encounter ID, patient NBR, and also pair code. So what is a pair code? We can see if you want. Pair code. Okay, because it is not showing like all these columns. Maybe whatever the pair code also. So we can eliminate of all this thing. X is 0 in place true. So guys, X is 0 here means like X is 1 means like our column, and X is 0 by default, which means our X axis, and which is my rows. So X is, because what we are trying to do, we are dropping all these features from my column variables, encounter ID, patient NBR, and pair code, and place true. So we just drop the variables. Now these variables are dropped. Now check NA in weight, because N has a lot of these kind of like the question mark null value, right? So we'll just take a quick percentage like shape 0, that is 0 is index divided by data dot shape. So around 96 percentage, like the null value I have in my weight column. So definitely I don't need this, right? But yeah, we can check like how many this kind of null values we have in other variables, the other columns. Again, the medical specialty, we can check how many percentage data we have, around 49%, which doesn't make any sense. So firstly, we just remove weight because it's hard to imputation and also irrelevant. It might can impute in future, we'll see, but for weight it has around 96%, all this junk value, so we don't need this. So we just drop this. X is 1 again means like because it's a column. And now no people have AIC blood test, because AIC also I have the column, AIC blood test also have the column. If you want I can show you also. Guys, the problem is it is not showing all these 50 category values. Okay, no worries. So no people have AIC blood test. Like if you want I can show you. Let me start my Excel, close my this. Yeah, AIC. What is AIC? AIC result. Yeah, it has a lot of null values. You can see this column, right? So what we can do, we can just check. No, people have AIC blood test. AIC may be some metrics like some blood test to diagnose diabetic or something. So we are just checking all this variable which is a more relevant. So either whatever is not relevant we just drop, and whatever is relevant we can just consider. Now calculate fraction of cases where AIC blood test was performed, like from total. Number of AIC were performed out of the total data, which is just less than, which is around 16%, which is again very less. So now replace missing data represented by this question mark by NA. So in my medical specialty has few data, right? Like, so what happened is, if you can see, uh, in the weight I have around 96% of uh, this kind of, like, data, which is a question mark. So that is why I have just dropped here. But in my medical specialty I have around 49%. The rest 51% we can still do with something. So what we can do, we can just replace by NA. Medical specialty underscore data medical specialty dot str, because it's string, and replace this thing with NaN value. So if you want to see, like, how it happened, so you can also see here. You can check the medical. No, see guys, now you can see now 2 rows 46 column, because we have dropped around 4 columns so far, right? And if you can see the medical specialty, see, earlier it was the question mark, now it has been replaced with NaN. And let's say it will make more sense if I just see in this way. Maybe not 10. 10 is again the huge number. Let's say 5. Yeah, medical specialty has a lot of NaN. Earlier it was question mark. So I was just telling you the pre-processing, like how the pre-process work, because last time I didn't able to show you like perfectly because of some technical glitch. So if you can see here, okay, my bad. Okay, it is not showing because it's okay, that's fine, but no need to worry, like yeah. So we were here. Then what we can do, remove remove rows that have NA in race, diagonal 1, diagonal 2, diagonal 3, and gender. Remove rows that have invalid values in gender. So in our data, like race, these all are columns, we have all this thing. So what we can do, we just remove with all this column, all this question mark with NA. If you want, you can again check. Now we can check our shape. So yeah, it's 46. Now we can find the unique values in my data set. Like in my age, I have this kind of intervals, like 0 to 10, 10 to 20, like 90 to 100, like this. So we can just check. Now check age feature. So what we can do now, in my age I have these many ages, like 1 2 3, these many group of ages. So I can group by with all of them, and I can see the plot. Yeah, you can see like these many people has the less diabetes, or maybe they have less admitted, 0 to 10%. Maybe the people are from 70 to 80, they have like admitted more, because it's a high chances to have diabetes with these ages, right? So you can infer like this way. Now recategorize age so that the population is more evenly distributed. Now I can just say like rearrange this. So we'll see after rearranging what happened. Yeah, so I'm just concerned about with these edges, like the 60 to 100. And so what we can do, we just scrub together, like one category is 20 to 60, one is 60 to 100. 20 to 60 and 60 to 100. Like earlier it was around 7 or 10, now it's only like this many. So now keep only insulin and remove the other 22 diabetic medicine, because these many columns, like I have the none values, and it doesn't make much sense to my data set. If you can see, like the other columns, it has no steady. So it maximum except insulin, because insulin has around 3 to 4 category, but the other columns they have only 2 categories. Like if you can just look at of all this thing, of all this column. So that is why we don't need this. The whole idea is the less number of variable you have, your model will perform better. The more chunks you have, the model will like perform like really bad. So what I can do here, I will just drop like data dot drop all this column. So this is your intuition, like you can just play around like how many columns you want to drop, and you can just check your accuracy. Then you can again go back and you can drop few more columns like that. So I can drop all this column as well. So now original discharge and disposition ID contains 28 level. Like so again, like this is some like so guys, it's quite boring, but yeah, like it is interesting when you understand all this thing. Then maybe like you can try by your own, and you can just play around like how these things work, right? Just a minute. Yep. So I think you guys are following me, right? Are you able to understand? Now the original admission source ID contains 25 levels. So this is again like so we are just doing like we are just like trying to identify, like we are just categorizing if the home if value 1 or else other discharge. So we are just dividing into the 2 or 3 categories, like the 28 levels, so we are dividing into 2 different categories. It has around 25 levels, but we are just categorizing like into 3 categories. So the less number of category we have, it will be easier for me like to do some analysis. So that is why like I'm just like creating a loop here. Emergency room if value equal to 7, else referral if value equal to else other source, like this. So it is very easy. You can just play around words. It has around 8 levels, and I'm categorizing into 2 levels. One is emergency, one is other type. So now this is the important thing. So what we can do here, so I have these many thing: age, race, gender, medical specialty, and all these are categorical value. So what I will do is I will change into categorical to numerical, like age data as type category. So this is the one line code. This is just a one line code, and you should always do like this thing. So we are doing as typing. So we are doing the categorization of like we are changing all this numerical categorical data to numerical data. So you can just keep change your, you can just pass the value and like assign in a different argument. That's it. You can say like the gender as type category, medical specialty. Because if you can see, if you can have a look of all this thing, age is a numerical number, right? But here age has an interval like 0 to 10, 20 to 30, 40, like this. If you can have a look of all this thing, like change diabetic medicine, you can just have a look a data set. Yeah, even in age, see, so this is not a numerical value, this is a categorical value, and we have to change it, right? to build our model. So after doing all this thing, what I will do, whatever is not needed, I will just drop that here again. So we are dropping our variables. So what error is showing here? Can use only dot category series with a category data type. Okay. I think this column has already been dropped, so that is why it is showing error, because I am just running this code like a second time. Okay, no. First I have to do this. So here what I'm doing here, I'm just changing, like I'm just doing the categorization, and here I am assigning. If you can see, like the age has become age 1, race has become race 1, gender has become gender 2, and so this is my new column now, and whatever the rest column has left, I will delete this. That is why it was throwing error. Now it's fine. Now what I will do, so whatever the similar kind of thing, whatever the similar kind of intuition, whatever the similar kind of column, so you have to find out, like like suppose age, salary, and a person, uh, like a like a age, a person's salary, and which company he is working, like a similar kind of company maybe. So you can group them together. So that is what we are doing. Like I told you, remember last time I told you we have to do this square root, logarithm, and transformation. Sometimes we have to do square root, sometimes we do the log transformation. So that is what we are trying to do here. Guys, we are already running out of time and we are almost about to finish. So just be with me for next 5 minutes maybe. Then we can just wind it up. So let data number outpatient dot apply. So what we are doing, we are just square root. We're just doing square root with all this thing. Like this is my previous value. And if you want to know like how this value come, so you can just check, like in my data outpatient it has this value. So if I do, I'm just doing my transformation. Like what I will do, I will just square root. I will just square root all this number, whatever the value has, number dot outpatient. I will just square root of all this thing. And now feature. So these are our. This is also called as feature engineering. So like the more you will play around with your data, the more the nice like what you can see, the nice model you will build. This is again the feature scaling I'm doing here. You can also call it standardization. So now these are the required package we have to install. Since I have already like do my all my pre-processing, so I will import all these packages. This is important to know, like sklearn, linear model, import logistic regression. Sometimes you have to use this oversampling input smooth. So smooth is basically when you have the huge class imbalance problem. Like suppose if I have a two class and one is 10%, one is 90%. Like suppose a 10% people they are not admitted and the 90% people they are admitted. So that means like it's a huge class imbalance problem. In that case we use this library that is called smooth. And this sklearn model selection import train test split from sklearn import matrix. So we impute all this thing, and I told you right, because we are trying to find out a re-admitted. This is a target variable, so we don't need this at this point of time. When you have the test data, so you can impute your test data and you can get the output, but at this point of time we can drop this also. X is 1 is always because it's a column. So X data dot drop re-admitted, X is 1, Y equal to data re-admitted. So I'll drop this column as well. So even if you want to see, if you can see your data here, let's say so now your data has around 24 columns. earlier it was around 50 columns, so now like we have around 24 columns so far. So here we have deleted, but again we have created y equal to data dot readmitted, right? So now this is something which we can do, and we can build our model, like split x and y into cross validation. So cross validation is another technique, like it's an advanced technique for like you can say when we do our like the split analysis, when we do our split, when we split our train and test data. So if we do the cross validation, it will give the more accurate output, like 75% on train and testing 25%. And this is the typical like code for this: x underscore cv, x test, y cv, y test, train test, split. And from sklearn linear model import logistic regression, from sklearn import matrix lg logistic regression lg dot fit x underscore cv, y underscore cv because like cross validation, that is why we are taking a cv. So here what we are doing, we are trying to fit our model lg, which is a logistic regression, and we are fitting our model with x and y. Always you have to take the train when you are fit the model, and when you predict, then you have to take the test data. This is a simple thing you should always keep in mind. So this is my training data, that is why I'm fitting here. Yeah, so this is your model has been fit. It is just giving the warning error, but that is we can ignore it. That's fine. You can see here logistic regression has built. Now we can fit like y predict is always wherein you can predict your data, and you pass the argument x underscore test and store in a y predict. And print accuracy of LG classifier on test data. This is something which you can do just to show like accuracy of, because this is something which we are printing. Print accuracy of LG classifier on test data. So this is your accuracy, which I was talking about, like how much accurate your model is. Around it will your model prediction is around 62%. It is not good, but yeah, it is decent. You can get like if you do more feature engineering, if you can drop your more variables and you can do some kind of feature engineering, then maybe you can like achieve 80% also. And here we can also have a look our error, like you can say these all are error metrics, confusion metrics. Like suppose this is my model, how do I identify whether my model is good or bad? So I can build a confusion matrix over here. The confusion matrix y test, y predict. So this is a simple like formula over here. So this is my confusion matrix, like y predict, like as I told you, right, like true positive, true negative, and all such thing. So why we need this confusion matrix? Because we are trying to find the specificity and sensitivity wherein we can build our AUC, our ROC curve. So our ROC curve will tell if it is closer to 1, that means our model is perfectly fine. If it is away from 1, that means my model is not good enough. Like from scalar matrix, import classification report. So we can find the classification report, like classification report will give you the specificity, the sensitivity, the accuracy, and such thing. Yeah, recall F1 score around 69% for 0, and for 1, like the people who got admitted, which is around 51%. People who didn't get admitted, which is around 69% out of these many people. So this is what you can info. Now store the predicted probability for class 1. So class 1 is basically for the people who got admitted, right? Like this is my prediction. And now I will plot the ROC curve because I have the data now. So ROC curve will give you the FPR, like the false positive and true positive, which is sensitivity and specificity, matrix.ROC curve. So I will just pass my all this variable here. So you can just label it whatever you want. ROC curve for diabetes readmission, false positive rate, true positive rate, in the form of grid search. Yeah. So you can see like my model. I have built my model. I have built the ROC curve as well, but it is not. It is quite away from one. And this is the area under the curve. This is ROC curve. If it is something like this, if it is something going like towards here, then I would say like my model is perfectly fine. But still, it's decent enough. Now AUC score. You can also find AUC score. Like AUC means like the area under curve. Print matrix AUC score we can find here, which is around 65%. Yeah. So if your model is good enough, then maybe you can reach around 85%, 90% or so. But yeah. So this is all about the logistic regression. In next class, we'll try to fix our issue, like because we have a little bit problem with the screen sharing. So we'll try to fix those kind of issue first, and I think the class will be more interesting. So guys, we are already running out of time. I think you also are sitting since a while. So we'll not address like the questions as of now. If you have any questions, you can just comment below and we can address maybe in the next class, because I can't see any questions right now here. Or what else we can do? Maybe we can discuss in next session. Next session will be mostly on let's say KNN, K nearest neighbor. Alright guys, thank you so much. Have a good evening. Bye bye.